Welcome to a lesson on energy stores. This is the first lesson in the GCSE Energy topic. My name is Mr. Pratt and I'm a Director of Science. So before we start, you're going to need a pen, paper or an exercise book. Unless you're having to view this video on your mobile phone, turn it off, put it on silent. Avoid whatever distractions that you can so you can keep your concentration. Straight away into the starter. What can you recall? So which of these two pictures is showing the most energy? Give some reasons. And how are they gaining or losing energy? 1 minute. So, which has got the most energy? Well, there's a couple of things you need to consider when you're deciding which one's got the most energy. Your first reaction is probably going to be the hotter it is, the more energy that it's got. That's right. But also the mass is important as well. Now, in both cases, the picture on the right of the glass pan of boiling water is hotter and bigger, so it's going to have the most energy. So reasons for the answer: it's bigger, there's more of it, it's more massive, and it's at a higher temperature. So how are they gaining or losing energy? Now, first of all, your cup of tea on the left, it's been made, it's hot water's come out of the kettle at about 90 degrees C, so it's then left on the side, so its temperature is going to be decreasing, so it's going to be losing energy, and it's going to be losing energy to the environment. It's going to end up heating up the room that it's in, so the tea temperature is going to drop and the room temperature will go up a tiny bit. The picture on the right is continually being heated, so there's energy from the burning gas, the chemical energy in the burning gas going into it, so its energy will be increasing, it'll be gaining energy. So the first outcome is to describe how energy can be stored in different systems. The important word really for the lesson is stored. Keep using that word. Talk about stores of energy. There's different types of energy that we talk about when we're talking about transfers. We'll come to them a little bit in this lesson, but mainly it'll turn up at a later lesson. And the other outcome is to explain how energy can move between stores of energy, from one energy store to another. So 1 minute then, let's just see what your background knowledge is, what you can remember from year 8. List 10 forms of energy. So just 10 energy words. Don't start with geothermal and solar. Remember, those words are describing energy resources that we have. So I want the forms of energy, the types of energy. Right, so give yourself 1 mark for each one that you get the These aren't in any particular order. It's got magnetic energy, electrical energy, sound energy, nuclear energy, light energy, kinetic energy, gravitational potential energy, elastic potential energy, chemical energy, and thermal energy. So now I'm going to give you 3 minutes in total. Which ones are transfers and which ones are stores? So which ones are the stores of energy? That might need a little bit of an explanation. We'll see how you get on. And then number 2, identify an example for each type of energy. So you might say chemical energy is stored in a piece of coal. So I've done that one for you. And there's one form of energy out of that 10 that can actually be an energy store and a transfer. See if you can explain to me how it could be both. So I'm giving you 3 minutes. If you use perhaps 1 minute on the first question and 2 minutes on the second two. Okay, so just be coming on to question 2 now, and I did chemical energy for you. Okay, just a minute left. You should be coming on to the last one, question 3. Okay, should be pretty much finished. So I'm going to start off with question 3. Otherwise I'm going to end up giving it away when I go over question 1 and question 2. So the box there, I'm going to put the little box around the one that is both the form of energy that can be a store and a transfer. So it's thermal. Well done if you've got that right. So a hot cup of tea could store thermal energy because it's hot. But also thermal energy, heat energy, would be transferred away from it as it's heating up the room through conduction, convection and radiation. So thermal energy can be both a store and a transfer. So question 1 then, which ones are transfers, which one are stores? I'm just going to mark the rest of the transfers now because there's only 3 more. So light energy is a transfer. So if something is glowing white hot, light energy is the energy that's being transferred away from it. So it's not an energy store. We don't store light energy. Sound energy. Sound energy is a transfer. It's a way that energy is transferred away from something else. It's not a store. And the last one is electrical energy, like electrical current flowing around a circuit. It's a transfer of energy away from the battery in a circuit. And all the rest of them there can be energy. You might, if you've got a really good memory, recognise this table from a year 7 or a year 8 lesson. So down there are the list of the energy stores. So all of those can be stored. And I've got examples for each one that you might have something similar to. So chemical, energy stored, chemicals in food, or you could have coal. Kinetic, any object that's moving is storing kinetic energy. So a car rolling down the road has got a store of kinetic energy. Anything that's been lifted high up has got gravitational potential energy. So just a book on a shelf or a ball on the top of a hill. Elastic potential energy. So if you stretch a rubber band or bend a ruler, it's got elastic potential energy stored in it. Thermal, so hot cup of tea. Magnetic, if you've got 2 magnets close together, they will be storing magnetic energy. Electrostatic, so when you've got static charge that can then make an object move, electrostatic, that's a store. And the last one, nuclear, so if you've got a radioactive material, because the atoms in it are unstable, that's the way that the nuclear energy is stored. Here's the 4 transfers then. I find it easier to think about whether something is a transfer or not is to think about a box, think about a shoebox. And in that shoebox, you want to put some energy stores. So if you put a hot cup of tea, you could put a hot cup of tea in that shoebox and you'd have a store of thermal energy in it. But if I shone a torch into that shoebox, put the lid down, took the torch out, put the lid down, if I popped the lid open again and peeped inside, I wouldn't see the light energy. The light energy has not been stored in there. Mechanical includes sound, because sound is vibration of particles. That's how sound is transferred. So if I shout into my shoebox and put the lid down, 5 minutes later, if I pop the lid off and listen, I'm not going to hear that sound. The only way that I could store sound would be, say I recorded my own voice on my phone and popped my phone into that shoebox. Well, now it's stored. However, it's not stored on your phone as sound. It's actually transferred to the storage in your phone. So it'll be mechanically changed into magnetic energy, and that's how it's transferred, just like on the hard disk of a computer. And finally, heating. So any object that's hot, heat will be transferred away through conduction, convection and infrared radiation. Okay, this man's got a famous name. I doubt very much that you're going to recognise him. He's very much got the beard of many scientists of the time. That's James Joule. So James Joule, you'll recognise the name Joule, English scientist, carried out measurements on energy transfers. So what he showed was that energy is actually transferred from one type to another, and it's not separate things. So that's why we call the joule the unit of energy. So he used kinetic energy and then finally transferred that into heat. His experiment actually was tricky and took him quite a long time. So he had falling weights and some paddles. So if you picture, on the right hand side we've got a falling weight and a pulley which is wrapped around there. So when the pulley falls, you had it a metre above the ground, as the weight falls, you end up with kinetic energy being stored as the weight is falling, which will make the paddles turn. So the paddles spin round, and the paddles are just in a tank of water. And you can just also see in there that he's got a thermometer in the water. So he starts off, he measures the temperature of the water, lets the weight fall, paddles spin, and then he goes back to measure the temperature of the water. Now initially he found nothing, so he was quite confused. The main problem with his experiment to start with was that his thermometer didn't have a big enough resolution, small enough resolution. He needed to measure to about 1/10 of a degree to actually measure it, because it's quite a small temperature rise that you'd get from that mass falling by 1 metre. So he's got an energy transfer from gravitational potential energy, so that's the mass to start with, being high up. That's then transferred to the kinetic energy store. So you've got your paddles spinning around in the water, and then those paddles spinning round heat up the water, so you end up with the thermal energy store as the temperature of the water increases. It's exactly the same physics that tells you that the temperature of the water at the bottom of a waterfall should actually be very slightly higher than the temperature at the top, because as that water falls, the gravitational potential energy is converted to kinetic, and then thermal energy stores the water splashes at the bottom. It's a very small amount, but it is measurable. So we're just going to have a look at energy in a slightly different way. So we've got the blue box. The blue box is showing you a full energy store, and the white box an empty energy store. So as one energy store empties, depleted, means getting less, the other energy store gets filled up. So the energy is just transferred from one energy store to the other energy store. Now, a very important law of physics states that the total amount of energy that you've got stays the same. It just ends up being in different energy stores or being transferred away through an energy. So let's have a look at a proper real life example of a candle. So we've got a candle burning, and that candle has got all its energy initially stored in its chemical energy store, because the wax is flammable. So you start off with a full chemical energy store, and then that chemical energy store is transferred to the heat energy store because the candle's hot. You've also got a heat energy transfer because heat is transferred away from that flame to the room by conduction, convection and radiation. And also because light is being emitted, you've got a light energy transfer. But the total amount of energy remains the same. So if I put a value and I say that we start off with 100 joules of chemical energy in that candle to start with, so 100 joules chemical energy stored, and then we end up with the candle getting hot, and that's 50 joules worth in the heat energy store, then we might have 25 joules that's been transferred away through conduction, convection and radiation for the heat energy transfer, and that must mean that we've got 25 joules transferred away as light energy. Same amount of energy at the start as at the end.
So, got a pendulum
set
up.
Just going to model using something quite similar.
Let's take the energy
with a
out
pendulum
of it.
in my kitchen.
I can get it perfectly still. So we've got no energy stored in that pendulum. When I lift the pendulum up, I'm raising it further away from the ground, so I'm giving it some gravitational potential energy because it's higher up than it was there. So I'm representing the amount of energy that I've given it by the liquid in that glass. So in that glass there, we've got the amount of energy in the potential energy store. And then as I let it go, the energy is transferred from the potential energy store to the kinetic and back to the potential energy store at the other end. So it's stop, but it's high up, fast, so that's the kinetic energy store, and then back to the potential energy store over there. So it just transfers potential to kinetic to potential over and over again as it's swinging past. So let's model that with the liquid. So the amount of liquid that we've got in that glass represents the potential energy store, and the amount of liquid that we've got in that glass is going to represent the kinetic energy store. So when it's high up, it's all potential energy store, but as it swings through the middle, it's all converted to potential energy, and then back to kinetic energy, and then back and back. So all the time it's just converting one to the other, one store to the other store. Now, you think I was just messy there? I've deliberately lost some of the liquid. The liquid that's been lost to the environment represents the energy losses when we're transferring from one energy store to another. So over a period of time, if I left that going, it would eventually stop, and that pendulum would stop because energy that was originally put into the potential energy store is lost to the environment through air resistance and friction.
Okay, so I'm going to give you a minute to write down the energy transfers in this animation. So I'm not after the energy stores, so it's the transfers. You've got 4 to choose from, 1 minute. Okay, should be just about finished off. So there's not a perfect answer to this. I'm going to talk about 2 energy transfers. So as that ball bounces, it will compress slightly and it will heat up. So there will be, as it gets warmer, there will be thermal energy that's transferred away from the ball into the environment. That's one. Also, as it bounces, it'll make a noise, it'll make a sound. And the reason you hear a sound is because sound energy has been transferred. So it's sound that's been transferred away as well. Now, sound you could have put down as mechanical, because mechanical is the movement of the particles, and that's what the transfer of sound is. Right, next one. So again, a minute. This time I'm after changes in energy stores. So I want you to think about energy stores that you've got. For example, you can't use sound now because we just talked about that being a transfer. Mechanical energy, which sound is a transfer. So a minute for stores. Okay, just about done. There's two main ones that we'll go with, and then we'll see if we can spot any others. So to start off with, as that ball is lifted up there, it's got gravitational potential energy store because it's high up. So gravitational potential energy store because it's high up. You could also have the gravitational potential energy store of the tree as it's high up and then starts to fall. As the tree is falling, it's moving, so there's also energy in the kinetic energy store of the tree, or you could have had the kinetic energy store of the ball as it's moving down. Okay, exam question then. So we got a motor, and the motor turns and the string gets wrapped around it. It gets shorter, lifts up the load. So the question is asking you to name the useful energy output from the electric motor. So it wants the energy store that you want to happen in this setup. And A part 2, what eventually happens to the wasted energy. So it's asking you about the energy transfers, because that's the way that the energy is lost. And then part B, give one environmental advantage of turning off electrical appliances when they're not being used. So an environmental advantage, not a financial one. 2 minutes. Okay, a minute gone. Right, just be finishing off. So A part 1 then. So that load is lifted so it becomes higher. So energy will be put into the gravitational potential energy store. If you've got kinetic energy store, then you're right, but that's the step before the load has been lifted. What happens to the wasted energy? Well, the answer to that question is pretty much the same whenever it comes up in the exam. If you just go with it's transferred to the environment, you'll always pick up your mark. But what will actually happen is the sound transferred away and the heat transferred away will all end up heating up the environment. Part B, give one environmental advantage of turning off electrical appliances when they're not being used. Well, a lot of our electrical appliances are using electricity that's produced from power stations that burn fossil fuels. So if you've put it reduces CO2 emissions, then that would be correct. Right, I'd like you to complete the Google quiz now. 10 multiple choice questions, and then you'll get your marks back straight away. I'm just going to leave you with a summary. As well as this summary, it'd be good idea to make sure that you've recorded the different types of stores of energy, and try and remember them. Make yourself a mnemonic to remember them. So we've got the law of conservation energy at the top. We've got a couple of basic straightforward questions in the middle. We've got the 4 ways energy can be transferred on the bottom left, and we've got the 8 energy stores there on the bottom right. So thanks for working away at that. I'll see you soon for another energy video.